Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. In this session today, we are going to study the velocity analysis by instantaneous center method. So far, we have covered various theoretically we have studied what is instantaneous center, what is instantaneous center, what is the definition of instantaneous center. The definition of instantaneous center is the center about which the body moves in relation to another body. That center is known as instantaneous center or simply known as I center. The number of I centers formula is n equal to n into n minus 1 by 2, where capital N indicates number of I centers and small n indicates the number of bodies or links. So, where is the number of I centers? N equal to n into n minus 1 by 2. This is the formula to find out the various instantaneous centers of mechanism having number of links. If 4-bar mechanism, the number of links of a 4-bar mechanism is number 4, n equal to 4, and capital N number of I centers or instantaneous centers equal to 4 into 4 minus 1, 3 by 2, that is 6. Similarly, if a number of I centers, if we consider it number of I centers, where if n equal to 5, the number of I centers capital N equal to n into n minus 1 by 2, 5 into 5 minus 1, 4 by 2, that is 10. If n equal to 6, the number of I centers equal to 6 into 5 by 2, that is 15. Thus, we find out the number of I centers by using this formula, that is capital N equal to n into n minus 1 by 2. The next, there is a theorem which is used to find out the location of the I centers. That theorem is known as Arnold-Kennedy's theorem. The Arnold-Kennedy's theorem states that if there are 3 links are rotating there are 3 plane bodies have relative motion among themselves, their I center lie on a straight line. That is the only theorem. The remaining portion of this theorem is about the theorem's description and validating the theorem. In order to support this theorem, describing the justifications, that is described in the remaining paragraphs, which is shown here in brace. This figure indicates how to validate the theorem, how to describe the theorem, how to justify the theorem. So, in order to justify the theorem, figure is mentioned here in favorable to justify the Kennedy's theorem. The three bodies are mentioned here: P body, Q body, and R body. This is R body, the bottom one, P body and Q body are side by side. Now, their I center lie. What is the straight line? PR and QR straight line. Suppose if the I center of PQ lies on the body P, then it should be in different direction. It is in the direction of VP. If the I center lies of PQ on the body Q, then it is in different direction. Suppose the direction should be remains the same, but here the directions are different. That means there is a logic, there is a wrong assumption that means why PQ is not on a straight line, that's why it is in different direction. If you PQ, eye center PQ is on a straight line of joining the PR and QR, then the direction remains the same. Alright. So that's why it is indicates that when three bodies have relative motion or having relative motion among themselves, their eye center lies on a straight line. That theorem, or this is known as Kennedy's theorem, is pronounced as Arnold Kennedy. There are two scientists. Arnold also found this theorem. Kennedy also proposed this theorem. Both the theorem are validated, or unknowingly it is coincidental that both are described the same theorem relation to find out the location of eye centers. That's why it is known as Arnold Kennedy's theorem. Next, suppose if this is the 4-bar mechanism, the 4 bars are there. The 4 bars are, this is the link 1, link 2, link 3 and link 4. 1, 2, 3, 4. How many eye centers for 4-bar mechanism? The number of eye centers equal to 6. What are they? Then it comes into the picture of types of eye centers. There are 3 types of eye centers. Number 1, fixed type eye centers. Number 2, permanent type eye centers. And 3, neither fixed nor permanent eye centers. What are the fixed eye centers are? How to know it? What are the eye centers? There are different methods are there in order to find out these eye centers are. One is that locate 1, 2, 3, 4 links. Combination 1, 2, 1, 3, 1, 4 with 2 combination 2, 3, 2, 4 with 3 combination 3, 4. How many eye centers are there? Are 6 eye centers. These are the types of eye centers. In the types of eye centers, we have to locate it first. 1, 2, 1 link with respect to 1, 2 or 2, 1 is this eye center 1. And 2, 3. The 2, 3 is marked here. And next 3 and 4 join here. This is another eye centers, that is 3, 4. And next 1, 3. 1, 3 is joined? No. 2, 4? No. What is next? There is one more eye center is there. This is the 1, 4. So here remaining 2 eye centers, this 1, 3 and 2, 4 are to be located with the help of Kennedy's theorem. 1, 3 means it will be 1, 3. It is connected to 1, 2, 3. 1 and 3 is there here. 1 and 3. It is connected in between. What is there? 1, 3 is connected with 1 and 3 links are connected. 1, 3 is connected with the help of 1, 2, 3, 2 link and 4 link. That's why 1, 2, 2, 3 extend. 1, 2, 2, 3 if we extend, and 1, 4, 3, 4 if we extend, that line will be intersected here. That is 1, 3 eye center. Mark. Next, what is link? What is next eye center? 2, 4 left. What is the 2, 4? 2 and 4 are interconnected with what? 2 link and 4 link. 2 is here, 4 is here. It is interconnected. There are 2 ways. One is in this manner, another one is in this manner. So 2, 3 and 3, 4 straight line. You extend the line. And 2, 4 is connected in this direction, clockwise direction. 4, 1 and 2, 1, 1, 2. You join. Intersection will be here. That is a 2, 4 eye center. Thus, we can locate the eye centers. Alright. We have to find out eye centers in that manner. There is one more methodology is there. How we have to join, that is here, pay attention. That is, there is circle. Mark on the circles link 1, 2, 3, 4. This 1, 2, 3, 4. Now 1, 2, 3, 4 indicates the link number. 1 and 2. 1, 2, 2, 3, 3, 4, 1, 4. This 1, 2, 2, 3, 3, 4, 1, 4 are directly available on the mechanism itself. But whereas 1 3 available, this 1 3 comes when 1 3 is the joining of two triangles. What are they? 1 2 2 3, 1 4 3 4 sides. This 1 3 diagonal comes by joining two things, 1 2 2 3 and 1 4 3 4. So 1 2 2 3, if we extend, so where is 1 2 2 3? This is 1 2 and it is 2 3. You extend this line, that is one straight line. Okay. Next, 1 2 2 3. What is the meaning? 1 2 2 3. This is 1 2 and it is 2 3. You extend the line. Next, 1 4 3 4. This is 1 4 and it is 3 4. You extend these two lines. This intersection point is the center, icenter of link 1 3. Next one, 1 3 is over. Next we want another one. What is the next one? 1 3 is over. Next 2 4. This 2 4 comes. How the 2 4 comes? 2 4 is the combination. That is the divide point of 1 4 1 2, 3 4 2 3. Where is 1 4 1 2? This is 1 4. This is 1 2. Extend the line. Next 1 4 1 2. 2 3 3 4. 2 3. This is 3 4. You extend this line. That intersection point is the icenter of link 2 and 4. So what is the physical significance of link 2 and 4? What is that meaning? The links 2 and 4 are rotating about this center. Okay, that is the meaning. What is link 1 3? Link Y center 1 3. I center 1 3 means about this center 1 3. Link 1 and link 3 are rotating. Okay, that is the meaning. What is I center 1 2? 1 2 is the common one. Link 1 and link 2's common point is that one about which it is. These are rotating. These two links are. Suppose link 2 is rotating about link 1. That means link 1 is fixed. And link 1 is rotating about link 2. That means link 2 is fixed. That is, in that manner we assume when the links are under motion. Okay. So this is what in the last class we have studied. So one thing is that among these eye centers, as we marked here, 1 2, what are the permanent eye centers in this? The permanent eye centers are 1 2 1 4. 1 2 and 1 4 are permanent eye centers. Next, fixed eye centers. 1 2 and 1 4 are fixed eye centers. Whereas 2 3 and 3 4, this is 2 3 and 3 4 are permanent eye centers. And remaining two, what are they? 1 3 and 2 4 are neither fixed nor permanent eye centers. That is the meaning. Neither fixed nor permanent eye centers. In that manner, we have studied in the last class up to this portion. These are the various methods in order to locate and how to locate and types of eye centers by using the figures, figure A, figure B and figure C. Okay. Now, we are going to study in depth and how to solve the problems by using this eye center method and how to find out how to do velocity analysis by using the eye center method. So before going to solve the problems, there are certain rules are there for locating the eye centers. So in figure A, and you can see then figure B and figure C also. In a pivoted joint, the center of the pivot is the eye center for the two links of the pivot. This is the eye center. And what is the rule number 2? In a sliding motion, the eye center lies at infinity, either upward or in the downward direction. Why? Because the point, it is like a straight line. The sliding motion is like a straight line, horizontal motion. So what is the radius of horizontal straight line? What is the radius of the straight line? The radius of the straight line is infinity. So by using that concept, the eye center of the linear motion of the components is at infinity. Next, here there are two bodies are there in figure C. In a pure rolling contact of the two links lies at the point of contact at the given instant. It is because the 2 points of contact on the two bodies have the same linear velocity, and thus there is no relative motion of the two links at the point of contact, which is the eye center. This is the eye center. So when 1 and 2 are rotating, the contact point is the eye center. At that point, the velocity of this point is 0. No relative motion here at this point. That point is the eye center. So very important concept now. This is angular velocity ratio theorem. So what is this angular velocity ratio theorem? So if we know if we know the angular velocity of the one link, and to found out the another angular velocity of another link, how to find out? We will use this angular velocity ratio theorem concept in order to find out such unknown angular velocities, provided one angular velocity value can be known. Otherwise it can't be. Suppose here, let me read. When the angular velocity of the link is known and it is required to find the angular velocity of another link, locate their common eye center, and the velocity of this eye center relative to a fixed link is same whether the eye center is considered on the first or the second link. For example, if we know the angular velocity of the link 2, we don't know the link 4 angular velocity, that is omega 4 to be, what is that? We have to locate the common eye center. That common eye center is the link 2 and 4. So we assume that first, link 2 velocity of the angular, let me read. If it is required to find the angular velocity of the link 4, when the angular velocity of the link 2 of a 4 link mechanism is known, locate the eye center 2, 4. Imagine, very important, imagine link 2 to be a circular disc, to form a flat disc containing point 24 and revolving about 1, 2, that is R point A. What is it meaning? Suppose link 2, what to do? This link 2 considered as a flat disc. This is the link 2. This link 2 is rotating with the angular velocity omega 2. About which center? About this 2, 4 center. Now, about which point? Here point A. Okay, now this link 2 is, that is 1, 2. So how to find out? What is the velocity? Velocity, linear velocity V equal to, or V24 equal to R omega, that is 1, 2 to 2, 4, or 2, 4 to 1, 2. That is the concept. Linear velocity V equal to R omega. What is that? R. Distance from the points. That is eye center 2, 4 to, but where it is rotating 1, 2, 2, 4 to 1, 2. That is V24 to omega 2 times 2, 4 to 1, 2. Similarly, imagine the link 4 to be large enough. Link 4 to be large enough to contain 0.24 and revolving about 1/4. This is the revolving about 1/4. Next, what is that? Now again make. This is the link 4, revolving about 1/4 point, and it is the 2/4 distance. But what is the angular velocity? Omega 4. Now V equal to, what is the linear velocity? V24 equal to omega 4 times distance from these two, 24 to 14. Now omega 4 V24 equal to, from this omega 4 equal to from this equation V24 by 24 to 14, that is the distance. From equation 1 we know what is V24, that is omega 24 omega 2 times 24 to 12. Substitute in this equation, that is omega 2 times 24 to 12 by 24 to 14, that is omega 4. Now omega 4 by omega 2 equal to 24 to 12 by 24 to 14. That is the equation. Here it is. Now this equation is known as angular velocity ratio theorem. What is that angular velocity ratio theorem? In other words, the angular velocity ratio of the two links relative to a third link. The angular velocity ratio of the two links. What are the two links? Are 2 and 4. Relative to a third link. It can be either become 1 or it can become 3. It is inversely proportional to the distance of their common eye center from their respective centers of rotation. Okay. Here omega 4 is inversely proportional to the 2414. Omega 2 is inversely proportional to 2412. This theorem is known as angular velocity ratio theorem. It is very important theorem in order to find out the unknown angular velocities of a mechanism, of the links of a mechanism. Very important theorem. Let me explain once again in scrutiny in a manner, in summarizing way. Very simple. If we know the link, if you want to find out the unknown angular velocity, provided knowing the another link's angular velocity. Suppose link 1 and 3 are there, unknown angular velocity you want to find. Suppose if we know the angular velocity of link 1 or angular velocity of link 2 and we don't know the angular velocity of link 4. To be found the angular velocity of link 4, first of all we have to find out the common eye center of the links 2 and 4, that is I24. Then let us go for, then what to do? Apply this linear velocity, what is V24 equal to, that is omega 2 times the distance from common eye center to particular link of rotation. And similarly next one, what is similar angular velocity, linear velocity equal to omega 4 of the angular velocity of the unknown link to distance of the common eye center to the rotation of that unknown link, center of that link. That is V24 equal to omega 2 times 24212. Here also V24 equal to omega 4 times 2414. What is it meaning here? V24 we said. That means linear velocity remains same about that common eye center of the two links. So link 24 may be having different angular velocities, but about the eye center their linear velocities remains same. That is the meaning of these equations. Okay. Now let us solve the problem in order to understand the better concepts of eye center. In a slider crank mechanism, the lengths of the crank and the connecting rod are 200 millimeters and 800 millimeters respectively. In a slider crank mechanism, the lengths of the crank and the connecting rod are 200 millimeters and 800 millimeters respectively. Locate all the eye centers of the mechanism for the position of the crank when it has turned 30 degrees from the inner dead center. Also find the velocity of the slider and the angular velocity of the connecting rod if the crank rotates at 400 radians per second. They mention here which method you have to use, eye center method or relative velocity method. Here already mentioned that there is a word, that word is called eye centers of the mechanism. That means we have to use eye center method. Now, data, this is the data. Based on the data we have drawn the diagram, that is configuration diagram. This 200 millimeter OAB, OA is the crank having 30 degrees inclination, 200 millimeter, and AP is the connecting rod having 800 millimeter length. Now, after drawing the configuration diagram, by using the diagram of eye center diagram, we have to locate the eye centers, either circle or a rectangle or a square you draw, and mark the links. How many links are there in this mechanism? Fixed link is 1, crank 2, connecting rod 3, and another one slider is 4, and the fixed link remains 1. So it comes under the category of 4-bar mechanism. So after knowing this configuration diagram, okay, we have to draw with the scale with a given geometric property. With the geometry we have to draw. Then after the start marking 1 and 2 eye center. This is 1, 2. Next 2 and 3. This is 2, 3. Another eye center. 3, 4. Where is the 3 link? 3 and 4. This is the 3, 4 eye center. And 1, 4. Where is link 4 and 1? Where it will be? The slider motion is horizontal. It comes under the category of a slider. This is the figure B. When slider, what is the rate? Eye center will be, eye center is at infinity. So the eye center is at infinity. That is 1, 4 is at infinity. The same 1, 4 is at a different instance, but it remains at infinity. Now this 1, 4 is transferred to here at 1, 4 because it is on the same straight line. Radius remains same, that is at infinity. Wherever it may be, it remains at infinity. It can be here, this point also. What is straight line? It is 1, 4 at infinity because it remains same. There is no changing of the instantaneous center. It is this translator motion or linear motion. Now we have to locate 4 eye centers. It's a 4-bar mechanism. For 4-bar mechanism, how many eye centers? N equal to 4 into 4 minus 1, 3 by 2. This is the formula, N into N minus 1 by 2. Where N is the number of links. 4 into 4 minus 1, 3 by 2. Now 2 times 2, 3, 6. 6 eye centers. Now here 1, 3 is left, 2, 4. How to locate 1, 3? 1, 2, 2, 3 you extend. Where is 1, 2? This is 1, 2 and 2, 3. You extend. 1, 2, 2, 3, and this diagonal is the joining of 2 triangles. 1, 2, 2, 3 sides and also 1, 4, 3, 4. Where is 1, 4? This is 1, 4 and it is 3, 4. Extend the line. This is the eye center 1, 3. Next, how to locate 2, 4? 2, 4 can be located by joining two links, by extending 1, 2, 1, 4. Where is 1, 2, 1, 4? This is 1, 2 and it is 1, 4. You extend 1, 2, 1, 4. Next, 2, 3 and 3, 4. This is 2, 3 and it is 3, 4. You extend either upwards or downwards. It is intersection here. That is I center of 2, 4. I24. In some of the textbooks, they used I everywhere. I14, I34, I13, I24, I34, like that. But no problem. It is location of two links combination. Okay, this in this manner we can locate the I centers of this slider crank mechanism. Okay, it is a just you have to location. After locating, next, how to find out the angular velocity? Now we have located. Now we want linear velocity of the I center 2, 4. The linear velocity of the I center 2, 4 equal to, where is the 2, 4 is located? This is the 2, 4 located. So we know the angular velocity of the link 2. V24, this V24 it is a common I center of 24 is the common I center of link 2 and link 4. Okay, so V24 equal to, what is the distance? Omega 2 times 24 to 12 distance. So what is the 24 to 12 distance? Or 12 to 24 also. This is the meaning. This distance you have to measure with the help of the scale and substitute here. Then it becomes linear velocity 2, 4 equal to omega 2 times distance from 24 to 12. What is it omega 2? Already mentioned. Where it is mentioned? In the problem. The crank rotates 40 radians per second. That is omega 2, link 2. The link 2 equal to 40 radians per second. Now 40 radians per second. 24 to 12, how to get it? You have to measure this distance, 24 to 12 distance, 24, 12 distance with the help of the scale. That comes as 0.123 meters. Okay, whatever distance comes, you mark it here, 0.123. Then the total velocity, that is linear velocity, 4.92 meter per second. In which direction? In horizontal direction. That is the linear velocity. Okay. Now, when this point is assumed in the link 4, it will have the same velocity, which means the linear velocity of the slider, is same as the 0.24. So that is the linear velocity of the slider is what? Which link? Is the fourth link. That's why, as I told you, these are linear velocity of link 2 and also linear velocity of slider. So that is also same as 4.92 meters per second. Okay. So here, very important points we can interpret from this problem. These I centers location in this diagram, configuration diagram, these I centers are located at this particular instant. If angle varies, this angle here, it is 30 degree and the lengths are 200 millimeters and 800 millimeters length of the connecting rod. Suppose if it is 45 degree, the location of I centers will be changed. If the angle is 60 degree, the crank with the horizontal is 60 degree, the location of I centers will be again changed. So these I centers will be changed from instant to instant, or from angles of the crank with the horizontal. Okay, thus, so at the particular instance, we are finding out at this particular instant the eye center is 2 4 and 1 3 here, and 2 3 1 2 1 3 4. If the instant position is changed here, if the angle is changing, the position, the location of eye centers will be changed. That's why these instantaneous centers are not dynamic. Dynamically varies, but at particular instant we are going to find out. Okay, and that means under static condition only you are going to find out these linear velocities. So at this condition, at this instant, what the linear velocity is linked to 4? That is 4.92 meter per second. If omega 2 varies, okay, then what will happen? It is increasing. That means linear velocity also increases. Okay. So it is linear velocity is the proportional to both angular velocity omega and the distances. So in that manner, we'll find out different linear velocities at a different instance of the location of the mechanism. That's why these eye centers are instantaneous centers. And we are going to find out velocities at particular instant. It is not dynamically varying. It is under static condition only you are finding out. So that is the model 1. So in this class today, we have studied what is introduction of instantaneous centers, types of eye centers, what is eye center, how to find out eye centers by various methods, and what is the notation of eye centers, and also what is the formula of eye center. That is formula equal to number of eye center, capital letter n equal to small letters n into n minus 1 by 2, and how to look at the eye centers by using Arnold Kennedy's theorem, and also solved the problem of a slider crank mechanism, how to find out the linear velocities of a slider crank mechanism for a given data by using this eye center method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.